Happy Thursday, 7th Accelerated. Today what we are going to talk about is we're going to kind of finish up our linear equations today and graphing linear equations. What we're going to go into starting on Monday is writing linear equations in this proper form, like your y equals mx plus b form, when it is not written in that nice form for you. And then we have systems of equations and we have some function stuff to finish up. So we're going to be going pretty quickly in the next 8 classes, I think, are what we have left. So today what I want to talk about is we are going to compare linear relationships. So we need to know, or we need to use what we know about our slope and our rate of change to compare either a table with an equation, a graph with an equation, a table with a graph, so forth and so on. Okay. So the first one, we're comparing two runners that are competing in a race. So I just want to preface this with think about running. Okay. In this case, running, when you're talking about speed, you want a faster time. So you want a lower number when you're talking about running times. Because, for example, when you guys run the mile, a 7-minute and 30-second mile is faster than an 8-minute and 10-second mile. Okay, so you want the lower number when you're talking about running. With that, let's take a peek. Runner number 1. The question's asking which runner is traveling at a greater speed. So this is asking just strictly about your speed, not your rate of change. So some of you are getting confused on that. Remember, your rate of change is your change in your y over your change in your x. Here, we just want to know who is traveling at a greater, faster speed. Okay, so runner 2, we can kind of quickly identify. If x is the number of miles and y is the number of minutes we take here. So if you ran 1 mile, so if I plugged in 1 for x, 9.5 times 1 would be 9.5. Therefore, your y, the number of minutes it would take for 1 mile, is 9.5 minutes. Okay, so we know runner number 2 is running a 9-minute and 30-second mile. 9.5 minutes. Remember, minutes are out of 60 minutes. Oh, mile, not plural. Okay, so that was our speed here. So let's take a look at this table. So here we know this appears to be proportional. Okay, that means it does go through the origin on a graph. So 2, 4, 6, 8, 18.5 to 37. Okay, if you were looking to find the difference between those, you would simply subtract. Okay, so that doubles if you take a peek at that. 18.5 plus 18.5 is 37. 37 plus another 18.5 is 55.5. 55.5 plus another 18.5 is 74. So that goes up consistently. Okay. So how we're going to check that is 18.5 divided by your 2. So this goes up, your rate of change here. Okay, you can look at it both ways because we're talking about speed. 18.5 divided by 2. When you throw that in your calculator, I'll throw mine up right here. 18.5 divided by 2 is 9.25. So what that means is it takes runner 1 9.25 minutes. So if you're trying to figure that out, if you guys think about 0.25 times 60, that's 15 minutes. So that would take this runner 9 minutes and 15 seconds. Did I say minutes before? I think I meant seconds. So 9.25 minutes converts, if you take your 0.25 of a minute, times that by 60, you get 15. So that would take you 9 minutes and 15 seconds for runner number 1. I'm going to double check that this is consistent. So I'm going to do 37 divided by 4. I get 9.25. 55.5 divided by 6, I get 9.25. 74 divided by 8, I get 9.25 again. Okay, so runner number 1 takes 9 minutes and 15 seconds, like we were talking about, to run a mile. Runner number 2 takes 9 minutes and 30 seconds. So who is traveling at a greater or a faster speed? The answer would be runner number 1 is traveling faster per mile. Okay. 9 minutes and 30 seconds is slower than 9 minutes and 15 seconds. I'll emphasize those with our minutes and seconds so you know the difference. Okay, that kind of justifies our reasoning. Another thing, if we wanted to write an equation to find our rate of change, if you found the difference here, the change in your y was 18.5 divided by 2, which is kind of what we did there. 18.5 divided by 2. So that you could easily write an equation with that. All right, so let's take a look at another one. This example, we are going to compare a graph with an equation. Equations tend to be easier to find our information in, okay? So this scenario is talking about the Smith and the Johnsons are both driving to family vacations for winter break. X represents our number of hours, and that's the same case over here on our x-axis for the Johnson family, hours. The Y represents the number of miles. Same thing on the Johnson family's graph. The y-axis represents miles. So for 1 hour, okay, if you plug in number of hours, 1 hour times 58 is 58. So that means you are traveling 58 miles per hour, okay? So that's your rate of speed here. So 58 miles per hour. And how would we find out how many miles per hour on the Johnson family? So let's take a quick peek. Are both of these equation and the graph, are these proportional? The answer is yes, because remember, if it's proportional, it's going to pass through the origin. Here, we do not have a y-intercept, so that is implied that it's going to pass through 0, because we don't need to put that plus 0 on the end. And this graph clearly passes through the origin. So both of these are proportional. So Johnson family, all you got to do here is find for the unit rate. I'm going to use this one because it looks nice and easy to use numbers. So remember, we're looking for miles per hour. So you divide your y divided by x, 100 divided by 2 is 50. So the Johnson's rate of speed is 50 miles per hour. Okay, so if you kind of take a peek here, you can see that crosses perfectly. That would be 50 if we filled that in. So 50 miles in 1 hour, 100 miles in 2 hours, 150 miles in 3 hours, so forth and so on. So which family is traveling at a greater, faster speed? So is going 50 miles an hour or 58 miles an hour in the car, assuming they're driving. Oh, yep, they are right here, confirmed. Faster. Hopefully we're saying the Smith family. Is traveling at a greater speed. Why? Because 58 miles per hour is greater than 50 miles per hour. All right, let's take a peek at this third one. This one's comparing a table with a graph. So our scenario, Bennett and Garrett are both saving money to buy new dirt bikes. So let's take a peek at this table. So our X values are our weeks. Our Y values are our total amount of money. So at 0 weeks, Bennett has already saved $115. So that must mean he has $115 in his account before he has even started to think about buying a new dirt bike. Okay, so we're going to find his rate of change. So right there, that tells us this is not going to pass through the origin. So this is not a proportional graph. If you're going to graph that, it's not a proportional relationship. Okay, so also, if I did convert this into an equation, y equals mx plus b. So I know my y-intercept at 0 is 115. Okay, so I'm beginning at 115 on my graph. And now we need to find, this is our slope or our rate of change. Remember, that is your change in your y. So what are my y is changing by over what is my change in my x. Okay, so you can grab your handy dandy calculator or subtract. Okay, so my rate of change appears to be 48. Okay, and we could subtract again we could subtract your 211 minus 163. That's also 48. 48. And that one checks out to be 48. So my rate of change, my change in my y is 48. My change in my weeks goes up by 1. So 48 divided by 1 is 48. Okay, so that's your rate of change. That's where we're going to begin. That's where his starting amount for saving is. So let's look at Garrett's account. Okay, here his is a proportional relationship. He's starting out with $0 in his account. And each week it appears, if you take a peek, here's where it crosses. He's saving $50 for 1 week, $100 after 2 weeks. He's got $150 saved at 3 weeks, $200 saved at 4 weeks, $250 saved at 5 weeks. Okay, so his rate of change, it goes up 50 over 1. Looking at our axis, up 50 over 1. So my equation over here would be y equals 50x. Our y-intercept is 0. Remember, we don't need to put that 0 there. So here, who is saving money at a greater rate? Okay, so Garrett, that he has a higher rate of change. So Garrett saving more money per week, even though Bennett started with more money. Okay, that's not what they asked. They didn't ask who had more in the end to buy a dirt bike. They're asking who is saving money at a greater rate of change. So in this case, Garrett's saving money. Okay, I fast forwarded so you don't have to watch me write. Garrett's saving money at a greater rate because $50 per week is greater than $48 per week. Okay, last scenario we're going to compare here is an equation with a table. So let's see what's going on here. This is referring to Lauren and Sean skydiving. Okay, so let's take a peek at what's going on in this equation. X is the number of seconds. And y is our elevation in feet. Where is Lauren in the sky? Okay, so it appears that she starts at 13,000 feet in the air. And what does this minus sign mean? That means she's going to descend or go down. If you think about skydiving, you're going to start, you jump out of your plane or your helicopter at 13,000 feet. And you're going to go down at a rate of 172 feet per second. Okay, so we put 1 in there, that's 1 second. Okay, or if we put 1 in there, 172 times 1 is 172. So you're going to go down 172 feet every second, beginning at that elevation. Now let's look at Sean's elevation in a table. So His X values are still, X is still the number of seconds. Y values are still our elevation in feet. Okay. So he's starting at where? At 0 seconds before he's even started his dive. He's starting at 12,500. So if we mimic this equation to help us compare, Sean is starting at 12,500. And I hope if he's skydiving, he's going down, unless he's magic, which we can see the Y values are going down. So let's find our rate of change. So we know it's going to be going down. So let's find out how much it's going to go down. 12,500 minus 12,150. I'm kind of helping you guys confirm. Let me get that out of the light. 350. So we're going down negative 350. Okay. Change in X values is 2. This goes up 2. So negative 350. Negative 350 divided by 2 is negative 175. So he's going down 175 feet per second. So now when you have these both written in an equation, it's really easy to help you compare. So the question we're being asked is who is descending at a greater rate? So we're looking for our rate, our slope. Lauren is going down at 172 feet per second. Sean is going down at 175 feet per second. In this case, where they started, it's not relevant to answer the question properly. So in this case, Sean, okay, because Sean is descending at a greater rate because going down, descending 175 feet per second is faster than descending 172 feet per second. Okay, after we finish that, you guys are going to answer some questions on comparing linear equations. And then what our last piece today is I want to do a little bit of practice on making sure that we are experts on graphing linear equations. Some of us on our slippery slopes had some messy graphs. So I want to re-explain and make sure that we fully understand what is expected of us when we graph. Okay, I know it's not the easiest to graph on the computer, but in PDF, they have those lines set out for you, and you need to put dots there. So here, given this equation, I'm only going to do a couple in each of these, okay? When we're given an equation in our slope-intercept form here, nicely written out in y equals mx plus b form. Eventually next week, we're going to start getting into stuff that's not written so nice, and we got to work to get it to that way. So you want to be able to identify your slope and your y-intercept. So my slope is 2. My y-intercept, making sure I include that sign, is negative 4. So when you go to graph, we begin on the y-axis at negative 4. So here there are no numbers, so we can assume that it's going down by ones. 1, 2, 3, 4. And my slope is positive, so that means I'm going uphill. So I'm going up 2 over 1, and I put another dot. Up 2 over 1, I put another dot. I've done this before, but I want to reemphasize. You need to have these points here. And best rule of thumb is you want to put as many points as possible to create the best straight line. So now you're running out of space here, so if you use your pattern to go back down, you can kind of see that waterfall effect. I can fit one more here to help me create that nice straight line. So I'm going to grab my straight edge. You don't necessarily have to have a ruler. If you do, great. Couple things you need to have on graphing a line. You need to have a nice straight line going through there. Some of us, you are drawing some real funky things. The other thing, you need to have arrows on the end, not an arrow over this point. It needs to be on the end because this graph will continue. If I expanded this graph out, it will continue in each of these directions. And then the last thing on our regents, you will lose a point, is you have to label your line with the equation that they give you. That would give you full credit. Okay, so I am going to hold you to the same expectations. So here, my slope is 1. My y-intercept is positive 3. I'm going to begin on my y-axis at +3, and my slope is positive again, so I'm going to go up 1 over 1. Remember, it's rise over run. If you don't have it as a fraction, then it's always over 1. I'm going to graph as many points as possible because it helps me create the most straight line possible. Remembering, straight line, the line's going to go past the points, and then you put arrows on the end here. And I'm going to label my line. Last one, when I have a slope with a fraction. So my slope is 2/3. My rise over my run just means I rise 2, run 3. My y-intercept is -6. So I'm going to find on my y-axis, -6. Still positive, so I'm going uphill. Up 2 over 3. And I can't do any more there. So if I come back down, I'm going left 3 down 2, left 3 down 2, left 3 down 2. It won't fit. So that is as many points as can fit on this graph, okay? Rule of thumb, when you have an open graph like this, typically on the Algebra Regents exam, you want to have a minimum of like, I want to say 5 points unless those 5 points cannot fit. So here we have 3 points, drill my line, have my arrows, labeled my line. Okay, just going to do 2 down here. Let's see. I'm going to do this one. My slope here, what number is that in front of my x? My coefficient in front of my x is a -1. You need to put it over 1 to help you see. You can. I do not have a slope here, so that means it passes through 0. Or I do not have a y-intercept, excuse me. So that means it passes through 0. Okay, so I'm going to begin at 0 on my y-axis. This is a negative slope, so it's going to go downhill. Down 1 over 1. Down 1 over 1. As you notice, when I go down and over, this creates a downhill slope. Okay, so connect your points here and label your line, and that will get you full credit. Okay, next one. Let's see. Let's do this last one. My slope is my y-intercept. Okay, begin on my y-axis at -1. My slope is negative, so I'm going downhill. Down 1 over 4. Down 1, that doesn't fit, so I'm going to come back up. And that would be off as well. So this one only fits 3. Drawing a straight line. Connect your arrows and label your line. Okay. All right, let's take a peek. I want to go over 2 here. Okay, a couple of us are still getting mixed up on this. These are actually nice ones because this does not have a slope. It does not have a coefficient attached to the x. Okay, so I do not have a slope, and my y-intercept is 4. So my slope is 0. My y-intercept is 4. So this is going to spear through the y-axis at +4. So remember, here's our y-axis. Okay, so all of my y values are the same. So it's going to spear through my y-axis at 4. So now let's take a look if we have x equals 1. That means it's going to go through my x-axis at 1. So taking a look, remember this is your x-axis at 1. So I'm going to put a point at x equals 1. Okay, and it spears through this point and goes straight up and down. Okay, my slope on these is undefined. My y-intercept, I do not have one. It does not pass through that y-axis. All right, Last one I'll go through because I think you guys are starting to get the idea here. I'll do this one. Our slope here is +1. We do not have a y-intercept, so it goes through the y-axis. So this is a proportional graph. My slope is positive. Okay, goes up 1. To save time, I won't draw all the other points just for video purposes. And label. Okay. All right, you guys are going to work on some practice. Next week, we're getting into when we get equations like this. They will not be in that form, so appreciate it now. Have a great rest of your Thursday and a great weekend. Miss you guys.